Welcome to today's Meet the Expert talk about knowledge graphs for sharing research data and information. In today's talk, I want to take a closer look into the following three subtopics: knowledge graphs for fair research data, research knowledge graphs of scholarly resource metadata, and research knowledge graphs of social science research data. Let's start with knowledge graphs for fair research data. When talking of research data, resources, and knowledge, what do we actually mean by this? We typically refer to things like research data, publications, machine learning models, applied research methods, and so on, and the relations between them. When it comes to searching for one or several of these, common questions for researchers may be, as an example, which top-tier publications cites which dataset or method, which data was used to train or evaluate which method has been conducted to produce what data, or which claims are supported or cited or rejected by what dataset or publication. In context of sharing and reusing research data and other resources, the following challenges arise. Data and metadata about resources and concepts is often not represented in a structured, machine-interpretable, and integrated manner. It is often hidden in publications or web pages. Persistent identifiers are often used inconsistently. Also, relations and semantics between resources, like between research data and publications, are often not explicit, which also makes it difficult to reproduce research results. These challenges are addressed by the FAIR principles, where the F stands for findability of research data, the A stands for access, the I for interoperability, and last not least, the R refers to the reusability of research data. Knowledge graphs can be seen as a technical solution to implement the FAIR principles. For example, a consistent use of persistent identifiers, like for example URIs or DOIs across all data, facilitates the findability of data. Data access, reuse, and linking can be improved by providing data via HTTP APIs. Interoperability and reuse can be enhanced by using established W3C standards for data sharing on the web, like RDF, JSON, shared vocabularies like schema.org, DCAT, DDI, among others. Data reuse can eventually also be improved by making links between resources and concepts machine interpretable, which supports information needs like which publication cite which dataset, and so on. When it comes to the scholarly domain, you may have heard the term research knowledge graph. What is typically meant with this term are knowledge graphs of research resources like datasets, research papers, methods, and concepts within the scholarly domain like authors, organizations, and so on. Research knowledge graphs can facilitate the way scientific outcomes are represented and utilized. Eventually, they facilitate the sharing of research data and information. So far the theory. On this picture, generated by Frank van Hamelen, you can see a collection of websites, companies, publishers, and many other actors who are actively using knowledge graphs in their systems. You may know some of them, but may wonder that you never saw a knowledge graph there. And this is because knowledge graphs are often implemented into systems in the back end. That means that a user is actually not seeing anything from that technology, but benefits from the rich information and data which is provided. One knowledge graph most of you have seen at some point is the Google knowledge graph. When you search for a certain term, you often see the result list on top or on the right-hand side, some info boxes which comprise several data and information coming from other sources like Wikipedia and so on. These info boxes are generated out of the data from the Google Knowledge Graph. which provides a huge network of entities like cities, persons, movies, books, or whatever, relations between them, and links to other data sources, which hold further information and data about these entities. Now, let's take a closer look at a research knowledge graph containing scholarly resource metadata. We can see here the GESIS search portal, in which the GESIS knowledge graph has been integrated and provides links between scholarly resources in the result list of a search. For example, users can see whether there are related publications for a certain research dataset available or the other way around. There is a Meet the Experts talk available giving more details about the GESIS search. The integration into GESIS search is based on user requirements. It has been derived from conducted online questionnaires and an observational study to reflect the requirements of social scientists. The knowledge graph related key findings here were that users are looking for research data mentioned in a paper, dataset search suffers from missing interlinks, and that literature search is an important part of dataset search. Currently, a log file analysis and another user study are in preparation to investigate the quality of automatically generated data citations. If you want to know more about this topic, there is a Meet the Experts talk available on understanding information-seeking behavior of social scientists. Let me now show you a small example of the interlinked data of the GESIS knowledge graph considering resources and concepts. We start with a dataset that comes along with some metadata. For simplicity, I only included few metadata items here, but of course the dataset carries more metadata. The dataset is cited by a publication, and the publication is also citing a survey instrument, which has been used actually in the dataset. While you can see links between the three resources, you can see also concepts included, marked in blue color, namely persons which are closely linked to a certain resource, but which can also be linked to from other resources. A person can obviously be author of several publications. Similar to the concept of persons, you could also imagine topics, for example, which can be referred to from different resources. To give you an idea of the extent of the graph, let's take a closer look at the links between the currently available resources. You can see that there are different types of links, or let's say links with a different semantic. For example, we can see that scholarly articles can cite datasets, while datasets can link to other datasets to indicate different versions of a dataset or the relation to a certain study program comprising several datasets. If we just look at the number of links between different resource types, that means without links from publication to publication and links from datasets to datasets, the GESIS knowledge graph contains around 98,000 automatically generated links and around 47,000 manually generated and curated links. Most of these links are internal links, which means that the linked resources are part of the knowledge graph. Only few links refer to external resources, so to publications or datasets which are not part of the GESIS search. Overall, this forms a comprehensive and interlinked network of the social science research domain. I was mentioning automatically generated links. What do I mean here? In our case, automatically generated links are the result of entity extraction pipelines for identification and extraction of dataset mentions in scholarly articles. There will be a Meet the Experts talk in July, which gives an introduction to scholarly information extraction. Currently, the GESIS knowledge graph is integrated as backend in the GESIS search portal. For 2024, we plan the public release of the knowledge graph, including publicly available Sparkle endpoint and HTTP API, as well as an RDF dump of the full graph for download. Last not least, I want to present briefly a knowledge graph of social science research data to show that knowledge graphs cannot only be used in the backend of a system and service, but also directly for research. TweetsKB is a non-sensitive, large-scale archive of societal discourse. It is a subset of 3 billion pre-filtered tweets which share tweet metadata, hashtags, user mentions, and dedicated features that capture tweet semantics, like for example, mentions of entities linked to Wikipedia and DBpedia, sentiment scores about emotions, and geotags for a smaller subset. This knowledge graph has been actively used to investigate the vaccine hesitancy in the DACH countries in context of the COVID-19 pandemic, where, for example, also the discourse to the topic Impfbereitschaft, so to speak, the willingness to get vaccination, has been investigated. At GESIS, we offer several research knowledge graphs of research data which can be used for conducting research. In June, there will be a Meet the Experts talk on how to preserve and analyze large-scale Twitter data. It is worth to mention that there are also other initiatives focusing on research knowledge graphs, like the Open Research Knowledge Graph from the TIB in Hanover, the many consortia within the NFDIs in Germany, the Research Graph Foundation, and the Coleridge Initiative as international initiatives, to name just a few of them. In the Department Knowledge Technologies for the Social Sciences at GESIS, we focus on knowledge graphs from different perspectives. We are developing tools for constructing scholarly knowledge graphs by using NLP and deep learning empowered methods for extracting large-scale knowledge graphs about methods, claims, data, or software involved in the scientific process. We offer these large-scale scholarly knowledge graphs, for example, Software KG, about the scholarly use of software and research data, or the already mentioned TweetsKB. And finally, we use our knowledge graphs to facilitate semantic search across scholarly publications, datasets, methods, and their relations, as in the example of the GESIS search. With this, I want to end this talk and thank you for your attention.